Okay, I think I'll start. Good morning, everyone. My name is Valentin Boursier. I am a second-year PhD student at INRIA, and and my research goal, is to make it easier to debug object-oriented programs. In this context, with Stephen Kostu, during the last year and a half, I've been conducting an empirical experiment on object-centric breakpoints. And today I will present you our preliminary results. So first, what is object-centric debugging? In the literature, it's an approach that describes a few amounts of object-centric breakpoints. Object-centric breakpoints are breakpoints that you apply in the source code of an object. And those kind of breakpoints only affect one object in your system. It is opposed to the traditional breakpoints, which are applied in the source code of a class and that affects all instances of that given class. In Faro, if you want to put an object-centric breakpoint on an object, you've got to open the inspector on the object that you want to target. You can select an attribute, an instance variable of that given object, and right-click on it to either choose to break the execution when this instance variable is read or written. You can also do the same on the methods that are supported by your object by selecting one method of that object and Alt whenever this method is called on this targeted object. The hypothesis of object-centric debugging are that it makes the process of debugging faster and requires fewer actions from developers. So we have strong insights and examples supporting this idea, but in the literature there is no empirical evaluations that support those hypotheses. So we designed one. Our empirical evaluation was composed of two tasks. One which is named Emolite, and the other one which is named Lights Out. Emolite is an application made to sort students into different groups depending on their level. And Lights Out is a game composed of small tiles that represents light switches that you can switch on and off. And the goal is to switch all the lights, but the one in the right corner doesn't want to be switched on. So that was the problem to solve. We designed our task to be equivalent in terms of time to debug and a number of actions required to debug the task. To ensure that our tasks are equivalent, before launching the experiment, we conducted 3 participations. And after those participations, we have not been able to say that there is actually a difference between those tasks. And after 59 participations during the experiments, we also conducted some testing of our hypothesis, according to which the task would be different. And again, the statistics test doesn't show any difference between those two tasks. So we consider them to be equivalent in terms of time and action required to debug Emolite and Lights Out. And this is with the standard debugging tools, not with the object-centric debugging tools yet. A bit more about the design. We divided our participants into 2 groups. The first group was debugging Emolite in control, so with the standard tools, and Lights Out in treatment with the object-centric breakpoints. The second group was doing the opposite, so they had to debug Lights Out with the standard tools and Emolite in treatments with the object-centric breakpoints. In between those two tasks, we added a tutorial and some warm-up tasks to train our participants at using the object-centric breakpoints. And again, we added some surveys to ask qualitative questions to our participants to know if, according to them, the tasks were difficult or not, and how did they found the tool useful or not. This whole process of experiment took our participants sometimes more than 2 hours, in average 1 hour and a half of performing some brain-intensive tasks. So I'd like to thank our participants, and I'd like you to give them a round of applause, please. Okay. As our tasks are similar in terms of difficulty, we've been able to compare the task in treatment versus control. And this is per participants. So this means that basically we did not consider the groups for now. So this is a diagram that shows how our participant performed in terms of time on the control task or treatment tasks. And there is no significant difference. The distribution is kind of the same, and except a few higher values in treatments that are reflected in the box plots, we cannot see any big difference. So for now, we cannot say that object-centric debugging helps developers to debug. That's bad, isn't it? But I don't believe that, so we performed another analysis, this time considering the groups. So one thing to pay attention on is that there is the higher values on the left side of the graphs. I don't know if I have a pointer. No. No. Okay. So for the group one, we can see that there is a negative difference, which means here that the treatment values are higher than the control values. And for the second group, this is the opposite. The control values are higher than the treatment values. So it appears that for group one, object-centric breakpoint doesn't help, but actually, it may have helped the people from the group 2. And people from group 1 had the lights out task in treatments. People of the group 2 had light in treatments. So the conclusion of that is that maybe object-centric debugging seems to help with light, but not lights out. Really? How is that possible, since we consider the task to be equivalent in terms of difficulty? So maybe it is due to the order of the task, or maybe it is due to the tasks themselves. So to verify this small hypothesis, we performed another analysis, and this time per task. So we compared the lights out task in treatments from the group 1 with the lights out task in control from the group 2. And we did the same with lights. We compared the treatment of group 2 with control task of group 1. And we see again those differences. It seems that object-centric debugging helps with lights, but not lights out. Again, the treatment's values are higher for lights out than the control values, and it's the opposite way for lights. To learn about those differences, which seems to come from the task themselves, we try to see how developers used the IDE when they were performing the tasks, when they were trying to solve the tasks. So overall, we can see that in treatment, so with the object-centric breakpoints, the participant used the inspector a bit more. And if we focus on lights out, we can see that they use the code browser more in control than in treatment, and they used the debugger more in treatment than in control. But we have seen before that for lights out, the difference is negative, which means that with object-centric breakpoints, the performance was less good than without those breakpoints. So we can wonder if the code browser is more efficient to help at helping developers to debug lights out than the debugger is when object-centric breakpoints are added to it. And there is an explanation for that. We found that explanation in the surveys results. It was reported by a dozen participants in the surveys that the bugs are of a different nature. To illustrate this difference, I made those diagrams, which are representing call graphs of the two simplified call graph of the two tasks. So on the left for amyloids, those graphs are divided into two parts. On top, the initialization part, and on the bottom, the application part. So in the initialization is the method that have been called during the initialization of the application, and on the bottom part is are the methods activated during the execution of the application. In yellow is the method containing the root cause, and in red are the failing object on which one would put a breakpoint. And what we can see is that amyloid has its root cause in the application part, whereas lights out has its root cause located in the initialization part. And so this means that for amyloid, you can reproduce the bug without having to launch again the application. Whereas for lights out, you have to restart the application to reproduce the bug. And this is the main difference between those two tasks. If you put a breakpoint on amyloids, you can trace back with the debugger the path to the root cause. Whereas with lights out, you've got to leave the debugger to observe the root cause, because the root cause is actually situated in the initialization phase, which is only observable in the code browser. Since when you put the breakpoint on the object, you have not anymore the access on the root cause. I hope this is clear, but if there is any question, I will be happy to answer them. Okay, so that's our conclusions. It seems that the object-centric breakpoints are helpful for a certain type of bugs, and not for the other type where actually your bug is not reproducible without restarting the app. So now we want to continue with our analysis and try learning about the relation between developers' experience and the data we observed and collected from our experiments. And we also want to learn more about the robustness of our data, to know if we can infer our conclusion to the real world. Sorry. And those results, we plan to publish them, to submit them at least, to the International Conference on Software Engineering. And after that, of course, we will continue to work on object-centric tools and build some experiments to learn more about the usefulness of the object-centric approach. Thanks again to all our participants. I thank you also for your attention. If you have any question, feel free to ask, even if you were not participating to the experiment, of course. Okay. Also, I plan to. Sorry, I was just adding something before. I plan to show in the show ESUG project how to solve the bug that were on the experiments. So if you want to answer, see if you want the answer or at least one solution to those bugs, I'll be happy to show them to you later in the day. Yep.
It's all very interesting. My question is, how can you even do that? Does it take any performance away from objects that are not do not have a breakpoint? So like I can see you doing object-centric debugging by having effectively a conditional breakpoint that says break, and if it's this object, halt. If it's not, then continue. But that slows down everything else. Does your solution slow down everything else?
Our solution modifies the behavior of the object. So we are basically rewriting the code behind the bytecode, but only for these objects. So it doesn't affect other objects of the image, and we are not checking that condition for every object.
Makes sense.
Executed in the
So you
system.
have a special method for that one object.
Yeah.
Excellent. Very interesting. Even despite your results, I find it a very interesting approach. I do similar things, but I have to have conditional breakpoints to do it. And this sounds much cleaner. So thank you very much.
You're welcome. Yeah, another question here.
Yeah, this is a little bit difficult to make this general reasoning about does a debugger help. So just to, if you take, because it extremely depends on the type of people and also on the type of problem. Extreme examples, if you just take to debug something which there's only a single instance of a class, then there is definitely no difference between object-centric and class-based debugging. But if you take something like debugging a list box of a central UI, which is used in all the browsers and all the tooling, then it's impossible to debug anything without an object-centric breakpoint, because it will crash the whole system even if you start debugging. So so then if you manage that, it's not that difficult to design totally extreme cases and different results where one of the debugging is preferred, or even it makes it just possible to debug anything. And without that, it would be just infinite time to find the bug. So it depends highly on the type of task. So you cannot just say, okay, they are equivalent on work. It depends. Yeah, as I thought on these type of examples. And also another thing is it depends on the type of person. So sometimes you show something a bug, they don't even need a debugger to just guess in 90% where the bug is. So there's no difference if they use a centric or non-centric debugging. And other people just working hours and hours on the same bug and don't find it, no matter what tool you give them. So the question is how you distribute the different type of developers into the two groups. How do you judge that they are really equivalent? And also, how do you judge that the problems are equivalent? Because it's easy to design in any direction.
Yeah, okay. So there's several questions actually, yeah. So first on the nature of the bug, of course, this is the next question. We want to learn which different type of bug there is, and for which one the object-centric debugging is applicable or not. Then for the design of the task, Ammonite is taken from the real world, so it's a bug that was in an existing application. And according to the literature, so the literature describes it makes the hypothesis, and then it describes the cases where the object-centric would be applicable, and this is what we wanted to verify. So we made sure that the tasks we selected were matching those criteria described in the literature, according to the people who were proposing the approach in the first place. I hope that answers the question. I don't remember the third one.
Yeah, maybe we have to also to a new exams that rely on the existing
Well, what's interesting there is that we selected the bug with regard to the literature, but what we observe is that actually there is a difference for one of those bugs, even if it matches the description from the literature, the tool is not efficient. So that's the results of the experiment. You want to add something? Yeah.
Yes, I just want to put some context also on the purpose of an empirical experiment, because first we have to rely on the literature to design the tasks, because else where are the corner cases described? We have no knowledge about that, and so but part of the research is about also discovering those corner cases. Okay, and we also have one other concern is that we cannot take extreme cases on purpose, because how can we compare anything if we purposely select a case where we know that it will work perfectly and one other case where we know it will never work and people could not solve the bug. So we have to find some balance, and this balance we find it by taking the literature and say what are the people who work on object-centric debugging claim. And the other aspect, because I was looking for the micro, so I didn't listen to the answer. Maybe it's it's a random experiment. Well, to be very rigorous, it's a quasi-experiment, and it is more or less random because the population is you, so you are not the real population of humans. So it's about the population of the Faro developers, and so you are assigned randomly to the tasks. To the groups, yes. So that means that we have people of different experiences, people of different background, diplomas, blah, 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 and they are all assigned randomly. So there is, of course, the risk to have bad luck and have one group with only experts and the other group which we compare are only beginners. So this is why, because we didn't want to bother you with statistics, but we have like correlation matrices where we try to look if there is correlation between the experience and the time spent, etc. And so because the random generator of Faro works well, so we were able to correctly dispatch the things, there is an even number of experts, newbies, and people PhD, not PhD, professional, professor, etc. in each group. So we cannot say that there is no bias. We can only say that we try to control this possible threat to the analysis doing that. And this is where we reach the limit of empirical experiment, is that we do not claim that this is the truth. This is just new evidence that we have to continue to explore.
Hi, Valentin.
Hi.
I just had a quick question. For debugging, I don't normally debug. I normally put self-halt. But in your implementation, you have a halt on read and halt on write.
Yes.
Does this exist in the normal debugger?
It's in Faro since the version 9.
To halt on a read or write of a variable?
Yes.
It is? Okay, thank
alt
you.
on read, alt on write, alt on call. They're in Faro since Faro 9.
Okay, thank you.
So you can use it if you want to try.
Am I correct that this is only I've only seen that in Faro, and only seen because of the flexibility of the language, and because in the advanced MOOC there was some mention, I think, of customization of individual objects. Mm-hmm. So it's based on that, I would say, technology.
That is the question, if it is based on the...
I never seen that in any language I've seen.
I think you can do it with other languages. In the literature, actually, it's described. Java, for example, is a good language also to implement those kind of breakpoints. The key here is to be able to target one instance in the system, and to modify the behavior of that object. So either by reflexive method, bytecode rewrites, techniques like this. But of course, in Faro it's easier because we have all those tools to help us rewrite stuff in the image and interfere with the normal behavior of the objects.
Okay, thank you.
You're welcome. Okay, that was the last question apparently, so thank you very much.